Fourth grade, lesson 11.2 is degrees of a circle. Our central question is, how are degrees related to fractional parts of a circle? So we're going to tie that to what we worked on in lesson 11.1. You can use what you know about angles and fractional parts of a circle to understand angle measurement. Angles are measured in units called degrees. Think of a circle divided into 360 equal parts, 360 equal parts all the way around. So that's a lot of tiny parts. An angle that turns through 1/360th of a circle, it measures 1 degree. So 1/360th is 1 degree. Let's see how this plays out in a problem. The angle between two spokes on the bicycle wheel turns through 10/360ths of a circle. Spokes on the bicycle wheel. What is the measure of the angle formed between the spokes? Well, what part of the angle does the spoke represent? It is 10/360ths. Let's use fractional parts to help with us. Each 1/360th turn degrees 1 degree. 10 out of 3/60ths turns a measure of, so 10 of these is 10 degrees. So the measure of the angle between the spokes is 10 degrees. Let's look at example 2. Find the measure of a right angle. Here is the right angle. We know it's a right angle because of that little symbol. Through what fraction of a circle does a right angle turn? It's 1 out of 4, right? 1/4 of the whole circle, like we did in the last lesson. If we were to split this into 4 equal pieces, we are using 1 out of the 4, right? So this is 1/4 of the circle. Okay, let's use equivalent fractions. Remember when we were writing equivalent fractions way back in chapter 6, I think it was, as long as we multiply the numerator and denominator by the same factor, the same number, then we're able to keep it equivalent. We have this fraction 1/4 with a denominator of 4, and we want the denominator to be 360. And I know that's like, whoa, that's overwhelming. But remember, we've got that 0 on the end, so let's temporarily ignore it. 4 times what number gives me 36? 4 times 9 does. And then put that 0 back on the end. So 4 times 90 is going to give me 360. They kind of walk you through this. 4 times 9 is 36. So 4 times 90 equals 360. So I did 4 times 90 here. And if I did times 90 to my denominator, then I must do times 90 to my numerator to keep the fraction equivalent. 1 times 90 is 90. And so we write 90/360ths in degrees. That's what we came up with. An angle that turns through 1/360th of a circle measures 1 degree. And an angle that turns through 90/360ths of a circle is 90 degrees. And probably when we were working on those right angles, you probably heard me several times say a right angle, a 90-degree angle. You probably heard me say that quite a few times because in my head, those are both exactly the same thing. A right angle is a 90-degree angle, and this is what we mean by that. So a right angle measures 90 degrees exactly, no more, no less. All right, well, let's try this. We're going to find the measure of a straight angle, the flat angle like that. Through what fraction of a circle does a straight angle turn? So if this is my circle and I have divided it in half here, and one of the sides is shaded, it went across and over as a straight angle. 1/2 of the circle is shaded. Write 1/2 as an equivalent fraction with 360 in the denominator. Okay, we have 1/2, and we want to turn this denominator from a 2 to a 360. Okay, well, if you're not sure, you guys, you can think through this process, but if you're not sure, you have the skill to find out. We know 2 times something equals 360. This is the reverse of multiplication, right? I've got to find this missing number. Do the reverse of it. 360 divided by 2 will give me that missing number, right? So if you're not comfortable with this part, then use this skill. You're already very good at. 2 goes into 3 once. 2 goes into 16 8 times. With none left over, I still need to go to the 0, 180. 2 times 180 is 360. So if I did 180 times 2 to get this, then I need to do 180 times 1, and that would be the measure of the angle, 180 out of the 360 of a circle. So the straight angle measures 180 degrees flat. So how can we describe the measure of an acute angle in degrees? So remember the right angle, I'll draw this here, right angle was 90 degrees. And when there's no angle at all, it's 0 degrees. And the acute angles were somewhere in between there, right? They were small, acute, bent over. They were smaller than a right angle. And so we can describe the measure of an acute angle in degrees by saying that it is less than, how much was a right angle? It's less than a right angle, less than 90 degrees. But it is more than 0 degrees, because then that wouldn't be an angle, right? So it's between, or we could say between 1 and 89 degrees. That kind of excludes any fractional pieces, but you get the idea. It's smaller than a right angle, bigger than 0. How can you describe the measures of an obtuse angles in degrees? Remember, those are the ones that are leaning backwards like that, but not all the way flat as a straight angle. So we know that it's going to be more than the 90 degrees, so it's going to be more than 90 degrees, but less than the straight angle, which was 180 degrees. Somewhere in between from here all the way down to here. So 120 degrees could be a possible obtuse angle. 179 degrees could be a possible obtuse angle. Anywhere in between, just past the right angle, all the way down to the straight angle, right before the straight angle. All right, let's look at the Sharon show. They want us to find the measure of the angle. Through what fraction of a circle does the angle turn? Okay, and they told us in fraction terms how much is being covered already, though we can kind of see that that is in fact 1/3 of a circle. If we were to split that like that, that's 1 out of 3. And so here is our fraction. We're again referring back to our skills we learned in chapter 6, equivalent fraction. As long as I multiply the denominator by the same number I do the numerator, it stays equivalent, it's just chopped up differently. We could think through it and ignore the 0 temporarily and figure out 3 times what number gives me 36. And maybe you know that, maybe you don't. And then add the 0 to the end. But if that's not something you want to do, your other option is, if I want to know 3 times what number equals 360, I can do this, because this is the inverse of that. 3 times what number gives me 360. This is a skill I have, right? We have this skill really well. How many 3's into 3? Just 1. Oopsie. 1. How many 3's into 6? 2. And how many 3's into 0? 0. And so there's our answer. 3 times 120 gives me 360. So I multiplied 3. We'll put the 120 here just so we can see it. We have 3 times 120 got us to 360. So we're going to do the same to the numerator. 1 times 120 gives us 120. That's easy. Identity property of multiplication, right? So the measure of this angle is 120 degrees. That's it. Let's look at this one. Tell the measure of the angles in degrees. This is 45 out of 360. Our denominator is already 360. So this is our degrees, 45 degrees. Done. Okay. We have 1/12 as a fraction. And in order to determine its degrees, I need that denominator to be 360. Okay, 12 times what number gets me 360? I'm really not sure, and I'm honestly not. So I always go to this because I can do this quickly. 12 times 2 is 24. 12 doesn't go to 3. So 12 times 2 is 24. 12 times 3 is 36. And 12 times nothing gives me 0. I need to get that 0 though. So 30 is the answer I'm using. So we multiplied by 30 to the denominator, so we must multiply by 30 to the numerator. 30 is our answer, 30 degrees. If this is making sense to you and you're ready to move on, go ahead. If you think you need a few more practice problems, I'll do a few more on your own. But if you're understanding this okay, you can go ahead and go into Think Central to get the assignment done. So they want us to tell the measure of the angle in degrees. They've gone all the way around 360 out of the 360 degrees. And if our denominator is 360, then we just use the number of our numerator as our degrees. So this one is 360 degrees. A full circle is 360 degrees. What about 1/10 of the circle being done? We have 1/10. If we want to know what the degrees are, we need the denominator to be 360. 10 times what number gives me 360? Hopefully you recognize with that 0 there that, and if I'm just looking at the 1 times 36, right? So 10 times 36 is going to give us 360. If you weren't sure, just do this. You would have seen it right away. 10 times what gives me 36? 10 times 3 does. And 10 times 6 gives me 60. So there you go. Oopsie, careful here, I just messed up, sorry. 10 times 36 gives me 360, not 10 times 360. Then we do the same to the numerator as we did to the denominator. 1 times 36 is 36. Now that my denominator is 360, that's my degrees. 36 degrees is the answer to that. And this section just wants us to classify the angles, kind of a review from before. Is it an acute angle? Is it an obtuse angle, a right angle, or a straight angle? So just to dust off cobwebs, acute angles are smaller than 90 degrees. Then they're smaller than a right angle, right? They're acute and small. An obtuse angle is larger than 90 degrees. That's the one that's leaning back, and it's hard to lean back sitting like that. Right angle, we talked about before, is exactly 90 degrees, no more, no less. And a straight angle is exactly 180 degrees, no more, no less. So with this here to help us, we have an 127 degree angle. It is more than 90 degrees. 90 degrees is here. It's leaning back more than that, larger than 90 degrees. So this is an obtuse angle. This little symbol here tells us this is a right angle, and so how many degrees is a right angle exactly? A 90 degree right angle. This is 37 degrees, which is smaller than 90 degrees. 37 is smaller than 90, right? So this is an acute, oh, I didn't put acute here. Acute angle, acute angle. And a straight line, 180 degrees, straight line, 180 degrees, that is a straight angle. So that's just kind of a review. We've kind of covered that before. And in any event, this whole lesson, if you're taking the fractional amount, if you want to know the degrees and your denominator isn't 360, then do your magic to make it 360. Just remember, whatever you do to your denominator, you must do to your numerator too.